All right, 3 past the hour. I think we're good to get started. We've got a quorum, and we'll accommodate folks as and when they join. But I just want to make sure we keep moving here, just for the interest of time here. Um, let me kick things off with the introductions. Mohan CV. I'm a lead architect at AWS, Amazon Web Services, and career-wise, I come with close to about a couple decades of industry experience, pretty extensive background in data, specifically around data warehousing, big data, with a specialty in data analytics, right? And when I was presented this opportunity to speak for this Codementor community, I thought I might as well just pick a topic that might just be relevant in today's digital modern world, and can be a better topic than application modernization, right? Speaking about the different architectural techniques that one can really employ when you're dealing with modern architecture, specifically on AWS, right? What does it look like when you work with a customer, and you're tasked to build a modern architecture on AWS? What does the journey look like, and what are some of the different architectural patterns, tools, processes, and frameworks that you all should be aware of, right, in this journey? And all of that we're going to be seeing is more through the AWS lens. Okay, so that's my intent. So you all can see the agenda on the bottom there. So roughly about 15 minutes each for each of the respective sections. We'll start off with a high-level introduction into the application modernization landscape, and then I'll kind of walk you through what the 7R strategies are on AWS. And then precisely on this call today, we're going to touch on three different areas, right? One is the rehost aspect of the applications. What is it? And then we'll touch on re-platforming those applications on AWS. We'll touch on what those approaches are, the toolings are, the frameworks are, respective to each of those rehosts as well as re-platforming strategy. And then a good focus of this conversation today will be around refactoring apps, right? Which is the third segment there in the agenda. Again, we'll touch on some of the architectural constructs, approaches, and tooling, and finally, words of wisdom. And we'll close with some key takeaways there. Okay, everything good? All good with the agenda? Any preliminary question before we get started, folks? I do see people coming in, which is good. So feel free to have your questions coming in on chat. I do not really want to interrupt the flow of the presentation, only because I've got enough slides to cover. But then if there's any pressing questions, if there's any question that anybody wants to ask, feel free to come off mute or keep your questions posted in the chat. We can address them at the very end, right? Depending on how well we go with the time overall. Okay. All right. I don't see any questions in the chat, so which is good. Let me just go ahead and get started. But before I get started, can you all just post on the chat for me in terms of what your cloud experience really is and your AWS experience precisely is? I just want to get a feel for who the audience is. Are you familiar with AWS cloud technologies and such? What's your skill exposure when it comes to dealing with AWS and cloud? Just give me from a scale of 1 to 5, 5 being the expert, and then 1 beginner, 3 intermediate, right? Just a feel for who the audience is, so that way I can structure my talk accordingly. Okay, so I get a 1, 3. Thanks, folks. 2.5 manual. Thank you. Okay, fair enough. Working on cloud migrations for the last 4 years. Knowledge of AWS is 3. Excellent. Okay, 2 production projects architected and developed. Awesome. So we've got a mixed group here, and I think my content here that I've got on this deck will really cater to all folks on the call today, right? But again, feel free to get your questions coming in on the chat, and I'll do my best to answer. Mostly serverless. Thank you, Damien. Okay, a good part of this presentation, at least the second half, will be focused around serverless. So I think that will keep you interested, Damien. Thanks for that. Okay. All right. So with that being said, I hope you guys can continue to see my slide. Can one last time, can someone confirm if you're seeing the very first slide that I'm presenting right now? the slide, the topic of the slide should say organizations are moving legacy applications. Is that what you guys are seeing? Are you still seeing the introductory slide? Can someone confirm that? No intro slide. So that's what I thought this application will do. I've tested this before. For whatever reason, I still kind of experience the same thing. I've gone past the intro slide into the next one, but some of this doesn't really keep moving. So what I'm going to do, I don't want to really troubleshoot this right now in the interest of time. I think this is all looking good. You should all see the second slide right now. I'm just going to leave it with this view and then continue to progress forward. Okay. All right. So let's get started, right? Just wanted to level set here. I know we've got a mixed group. I did see a couple of zeros and ones, so there's definitely good number of folks here on the call who's starting their journey afresh. So for those that are really starting their journey on the cloud, now, if you really look at it from a customer's landscape, we hear from a lot of our customers every day that they want to transform their businesses. They want to transform their applications at scale. The priority for each of those particular customers may vary, but then the goals for all the customers will remain the same, right? One is to reduce the cost. They want to become more agile, and they want to drive and foster innovation within their organization. And they want to improve their bottom line, which is to reduce their operating costs, and in the process, sort of improve their overall security posture and compliance posture, right? And kind of really enhance the overall customer experiences for their organizations at large. So the goals are going to be pretty much the same no matter what customer and which customer is really dealing with this legacy application migration to the cloud, right? So keep that in mind, and every journey for every customer is going to be different, but then the goals are going to be remain the same. There will be customer that you will run into who has got a well-established on-premises landscape. They want to migrate to the cloud on AWS, so maybe they might just be looking at a lift and shift, sort of moving their workloads over to the cloud on AWS. Or you could be customer scenario number two, where you have a similar customer with a well-established on-premises landscape. Rather than lifting and shifting their workloads, they have a well-established IT presence, right? They might just come to you and say, you know what, we don't want to just migrate our workloads over to AWS. Rather, we just want to modernize them as we migrate them over, right? So that's another scenario. Now, the third scenario is where you will run into customers where these are customers that are born in the cloud on AWS, right? They start the journey on the cloud on AWS from day one, building new applications cloud native on AWS, right? They don't really have any technical legacy depth whatsoever. Rather, they just start afresh. They start their journey afresh on the cloud on AWS. So the multiple different scenarios that one might run into, I'm just kind of breaking it down just for those folks who are relatively new in this journey. So keep that in mind. So as you start enhancing yourself, as you start building your skills, you probably will have to really target each of these different customer segments. One that migrates their existing workloads, two, migrating and modernizing their existing workloads, and then the third scenario is where they want to really go cloud native. Okay. And then the market presence is so huge, the opportunity is so huge today that we still see in a good percentage of customers, the statistics say greater than 50% of the existing customer community are still yet to be migrated to the cloud. So such is the volume of the opportunity that exists today. So if you're really starting a journey, I think there can't be a better time than this to really enhance and push your barriers forward. Okay. All right. So with that introductory note, I really want to cut to the chase here. Just wanted to dive into the actual core focus of this conversation. For the rest of the conversation here, we're going to be using a 3-tier web application as a template to really navigate through a conversation, right? So this 3-tier web application that you get to see here, if you're familiar with the 3-tier web application, as the name suggests, you've got the very first layer at the top, which is a web layer, right? Which is a web front end. and then you have the second layer, which is the application layer. That is where your application logic really resides. And then you have the tertiary layer, the third layer, which is the data layer, right, where technically all the data gets stored. So this is typically a very generic or generally looking three-tier web application that you get to see within the customer's on-premises landscape. Now, my question for this particular group on the call here is, given the focus of this conversation today being refactoring, can someone just throw your thoughts on the chat as to how would you refactor such an application that you're seeing on the slide? This is a very legacy looking monolithic application, but how do you go about refactoring this on the cloud on AWS? Especially, this is more a question for the folks that have a reasonable amount of experience on the cloud. Can you just post your thoughts on the chat for me, please? Or maybe if you want to just come off mute and share your thoughts, that'd be great too. Oh, Bala, are you not able to see my deck? I mean the slide that I'm presenting. I'm showing a three-tier web application here. Is that the case?
No, I'm not able to go on.
No, is that the case with everybody as well? Can someone else confirm that? Yeah, a sample application is what I'm showing. Okay. But I think everybody else are able to see my slide.
Okay, let me try.
Yeah, or maybe I can just stop sharing and I'll reshare again. See if that helps. I've stopped sharing. I'm gonna reshare it again. Okay, back on the sample application slide here, Bala. So see if that helps. Okay, I see some responses in the chat coming. Thank you so much. Replace all services with IaaS services, infrastructure as a service services. That's good. Christian, thank you. Zero changes. Create a VM image and deploy for IaaS. That's good too, Howard. Thank you. I can see the sample. Okay, that's fine. From manual, excellent. From monolith to microservices, absolutely. So when you talk about refactoring, getting into the microservices world is where you really reap in the most benefit out of, right? For corporate data center, I'll create a VPC and configure EC2s in that VPC. Excellent. I think I've got a mixed response. There's no right or wrong. I think each one of you has really hit a different area of how a customer can benefit from having to migrate and modernize such an application that we are seeing on the slide, right? The response towards microservices is more catered towards the refactoring of the application itself, while the other responses that I see on the chat are more centered around the migration aspect, right? The rehosting aspect, which we'll quickly touch on in the next coming slides. Could be ECS instances with images, absolutely. Microservices without Kubernetes. Excellent answers, Damien. Thank you so much. So yeah, so that's good. So let's keep moving here. Yeah, so these are the challenges. Again, just to kind of iterate on the previous slide, some of the business and technical challenges that you'll run into are listed here. I'm not really gonna read through the bullets here. I will leave the deck with each one of you. I'll share it, in a central forum from where you can download the deck for your benefit. But what I really wanted to address is the 7 R's, right? That you can really target to really transform the three-tier web application that we are really talking about. So those 7 R's are basically what is listed on the slide on the right that you see. So let me just quickly take a minute to really go over each one of those different R strategies. The very first is the rehosting strategy, which is the second one, easily the most popular and the most common of the lot here, which is to lift and shift the existing workloads over to AWS, right? And AWS, specifically speaking, does a good job of giving you all the necessary tooling and the frameworks in place to really accelerate your rehosting process. Think of this as more like apples to apples sort of migration, right? Someone in the chat said, nothing really, just transform them, create an image, deposit as EC2 instances on AWS. That's as simple as it can get. So that's basically the rehosting strategy for you. The replatforming is where you make subtle differences, subtle changes to your your application in a way that it can really perform well in the new platform, right? In a managed platform on AWS. So think of this as more like a SQL Server database running on premises, and then you want to really move away from the self-managed SQL Server database to a more managed version of the database on AWS, right? Something like RDS for SQL Server on database. We're not going to really get into what is RDS, the fundamental aspects of AWS and cloud. I kind of assume that everyone can really follow me with all those what tos. But anything that anyone is unable to correlate or comprehend, please let me know. Post your questions in the chat. I'll do my best to answer. But I kind of presume that everyone knows what an RDS is, relational data store on AWS, and then moving away from the self-managed SQL Server to the RDS for SQL Server is re-platforming that database onto the AWS cloud to reap in additional benefits, right? So moving into a managed service platform sort of eliminates a lot of manual intervention that one will have to do. So that's re-platforming, lift, reshaping, and then working on the cloud with a managed service offering. And then you have the repurchasing. So repurchasing is where this is a strategy where you're moving away from the traditional proprietary, the traditional perpetual-based licensing model to a more usage-based SaaS licensing model, right? Think of SaaS offerings like Salesforce, Drupal, things of that nature, SaaS offerings that you can really purchase and then use it on the go and then pay only for the consumption that you do, right? So that's repurchasing there. And refactoring is where this is a strategy where you sort of redesign and re-architect your entire application to really take advantage some of the latest and greatest of what technology, the latest and greatest technologies of what cloud can offer, right? This is where concepts like containerization, microservices, DevOps, and more app code development, all of those come into picture. So that's refactoring for you. And then the very first thing, relocate, is a new strategy. This is where if you're dealing with customers that have got a fleet of VMware instances running on a VMware virtualization platform, and if you really want to accelerate such migration onto the cloud on AWS, relocate could be a very good strategy. So we have our managed VMware offering called the VMware Cloud on AWS, VMC on AWS, right? So which you don't necessarily have to modernize those workloads over. Rather, you can just relocate the existing virtualization platform that's running on VMware onto the cloud on AWS using this VMC offering, right? So as simple as that, it can really help the customer accelerate the migration, bring them to the cloud on AWS, give them a quick successful run on AWS, and then as an iteration to think about modernizing their workloads, right? Either through containerization or microservice or whatever, right? So that's relocate. And then the last two, retain and retire. Now, as you're starting to analyze your customer's existing portfolio, I'm pretty sure there'll be a significant percentage of workloads that might just be zombie workloads, right? They might just be sitting there idle, not really adding any value at all. So those are workloads that can safely be deemed to be retired. And you really have to watch out for such workloads to eliminate those workloads from your assessment before you actually plan your migration, right? So that way you can eliminate a good percentage of workloads that are unnecessary and focus on the ones that you want to bring them over to the cloud. And then retain. These are workloads where you really want to just keep them running on premises for various different reasons, right? If you're really running into a very regulated customer with regulated workloads, strict conditions, government regulations really imposed on such workloads where the data and the workload, the nature of the workload is such that the data needs to be residing in a particular geography or a territory. Such regulated workloads has to be retained and be made running in the on-premises environment. So think about that as you really perform your assessment of a customer's landscape. All of these different strategies, the 7 strategies, will have to be employed. So eventually, when you really come out of the assessment, what you will have to do, and in fact, the output of your assessment should be a migration wave plan that should really say, okay, here's all my 100 different workloads that I'm going to be migrating over. for each of those workloads, here is all the strategies that I'm going to employ, right? Server number one, I'm going to employ rehost. Server number two, I'm going to refactor such your mind into your assessment process, and then use these 7 strategies to really help you put together a wave plan. Okay. All right. Any questions so far? Can you please tell us more about the repurchasing by using examples? Yeah. So repurchasing. So if you, in simple terms, right? So if you really look at the traditional purchasing model, right? So I come from a data world. Business intelligence happens to be a lot that I have worked. So if you really look at it, look at the business intelligence tools, say for instance Tableau or SAP Business Objects or MicroStrategy, they have a very perpetual based licensing model, right? They say, okay, for a given user, this is the X amount of dollars that one need to pay for the entire year. No matter how much that particular user is really using the software, that X amount of dollar has to be paid to the vendor, right? So if you're really overutilizing it, then that's good, right? You're a happy customer. But if you're underutilizing it, you still end up paying that full amount for that licensed user to the vendor, right? So that's how the traditional model worked. Now with the pay as you go model, with the more SaaS based purchase, so you're only paying for the consumption that you use for that single user, for the amount of time that the user is really using that particular software. That is the consumption for which they're paying, right? So that the cost, if you really look at it, it's going to be significantly reduced when compared to the traditional model, right? Does that make sense? I just gave a very simple example, but then there's a lot of nuances around the licensing there, which is not the focus of the conversation, but hopefully you got the essence there, Mohammed. Yeah. Okay, excellent. Thank you. All right, so let's just move on with the same 3-tier architecture on the left. The very first thing. So now for the rest of the conversation here, we're going to touch on 3 aspects, right? We saw the 7 R strategies, but we're going to just focus on the rehost first, secondly the replatform, and then thirdly the refactor, right? So this is the architecture for what a rehosted workload will look like. For the 3-tier web application on the left, if you had to just rehost, lift and shift it on AWS, the resulting architecture will look something like the one that you see on the right, right? So technically, you will identify a region, you will have a VPC, virtual private cloud, that you will set up. So that will define your networking boundaries, right? What your availability zones are. You will then have your own private public subnets that you will define as part of the VPC creation. Now, how your 3-tier web application will translate to the AWS architecture is the web and the application servers will be translated into AWS as EC2 instances, right? You're lifting and shifting your web app into AWS as EC2, a fleet of EC2 instances running within the region across one or more availability zones, right? Now, whether you want to have both your web and your application all combined together in a single EC2, or you want to just break it down into multiple tiers, is totally up to you. But then the point that I'm trying to make is you're going to have a fleet of EC2 instances running behind a load balancer, right? On AWS, we've got different types of load balancers, but then the ideal load balancer for web application needs is the application load balancer, ALB. Elastic load balancer is a very generic name, but then you have application load balancer more for HTTPS and HTTP rendering, and then you have got network load balancer, right? If you're dealing with UDP, TCP traffic, the network load balancer might just be a good fit. But then for this particular scenario, since we're dealing with a web application, a monolith web application, having a fleet of EC2 instances behind a load balancer is a perfect fit. Now for the data tier, we have the Amazon RDS, relational data store, which is a managed offering. So you don't really have to deal with a lot of manual patching, upgrading, and whatnot, right? That comes with the traditional architecture. Amazon AWS here takes care of all the undifferentiated heavy lifting for you. All you have to do is just host those database workloads on AWS, and then continue to do your daily operations while leaving all the mundane day-to-day stuff to AWS to take care of, right? So that's the database layer for you. Your database is no longer a single point of failure. Your database is resilient. As you can see here, you have a primary database in an availability zone 1, and then you have a standby database, a secondary database to your primary, which is stood up in another availability zone. So that way you have the replication going back and forth between primary and standby. So at any given point in time, your standby will be kept updated. Should there be a problem that occurs, right? If let's just say, for the sake of the conversation, if your entire availability zone goes down, your primary database is taken out, right? So that's when your standby takes effect, comes forward, takes over the primary, and then that will ensure that your front end application will still continue to be running. So the architecture that you see on the right is still resilient, distributed. We're not really doing anything fancy. It is still a lift and shift architecture. It is not a modernized architecture per se, but at least the customer will still significantly save a lot of cost compared to the traditional architecture, right? You still have got the customer to step one on AWS, right, and help them to save a significant amount of cost, right? So that's basically what this rehost is all about. And then on the right, CloudFormation. If you're familiar with CloudFormation, or if you're familiar with Terraform, Ansible, or any other infrastructure, coding, scripting framework, CloudFormation is our native way of really scripting your entire infrastructure, right? AWS infrastructure. S3 is where you store your static assets, right? If there are any static configuration files, images, videos that you want to render on your application, S3 is a very durable object storage where you can store it. And then code repository is much like your GitHub and other code repositories that you use, right? This is a native version. So all that you see here on the slides are the native option, but then you're absolutely free to really use your own non-AWS options as well and integrate with the AWS ecosystem. It's perfectly fine. And CI/CD pipeline is basically how you go about stitching together a DevOps pipeline for your architecture. But what I wanted to really convey on the slide is for your lift and shift, which is the rehost strategy. It is as simple as really bringing your servers into AWS as EC2 instances. And then tooling-wise, we've got our native tooling in Migration Evaluator, which has got the Cloud Endure technology underneath the scene. Did I say Migration Evaluator? So no, Migration Evaluator is more for the assessment purposes, but then the actual tooling is the application migration service, right? Previously called the Cloud Endure, which is the service which actually helps you create an image of your on-premises system and then move that over into AWS as EC2 instances, right? So I'll leave it at that. So hopefully it is all clear for everyone. If there's any question on rehost, please feel free to post it in the chat. Read replicas will be great over there. Again, yes. I'm not really saying that this is a complete looking architecture for rehost. What I've given you, or what I'm trying to show you here, is a very first iterative version of what could be a rehost architecture on AWS. And of course, you can certainly build on top of this, right? You can add read replicas, or you can even bring elastic cache, right, in front of your database to cache your read queries coming out of your application to really speed in your processing times. Absolutely, right? You're absolutely spot on. Generally, we have three-tier architecture most of the time. So in enterprise apps, do we have always a three-tier, or it can be as many tiers as it required? Yeah, like I said, it really depends which customers your customers or customer segments you're working with, right? So if you're really dealing with, at least from my experience, if you're really dealing with greenfield customers, or at least brownfield customers to a certain extent, you will really find those customers really having their web and application tiers all merged into a single tier, right? But as you really navigate into the bigger customers, the enterprise customers, the large customers, so they will have a sophisticated networking boundaries, a well-established DMZ zone. They will have independent tiers for each of the respective application construct, right? They will have a separate tier for the web, front end. They'll have a separate tier for the application logic, which is the app server, and then they'll have a separate tier for the database. So it really depends on the customer's appetite and what sort of a networking architecture they have, right? That really determines their AWS architecture they really want to support. I mean, if the customer's IT exposure or IT footprint, right, if their resources within the technology team is so limited that they can only manage a very subset of the workloads that are running in production, they're not going to really expand their boundaries, right? So those are customers where you will find they really merge all the tiers and consolidate them into just a single tier, one tier for the web and app, and then one tier for the database. Does that make sense? I hope that answers your question, Mohammed. All right. Okay, so with that, let's just keep moving on. So there are a few things that you really want to keep in mind as you're really moving your customers' workloads onto the cloud. Make sure there are fundamental things that you want to just address. One, updating make sure the operating system is updated. The frameworks that the customers use for the web and application layers are all upgraded, right? Which, of course, if you're really using a managed offering, AWS will take care of it. But then in case of EC2, where you are responsible of managing the operating system, the underlying frameworks, it's important for you to keep those upgraded on a regular basis, right? And then improving the security posture overall, and then having the right fine-grained access mechanism, right? And exploring database options, the right database options for the right purpose is key. So a relational data store might just not be a good fit for all use cases. Maybe for the three-tier web application that we're talking about, RDS is a good fit. But then if you're really getting into a lot more creative and a much more different use case, RDS might just not be a good fit. So remember make sure you really educate yourself with all the database options and pick and choose the one that is apt for the use case that you're working with. Okay. All right. I don't see any questions in the chats. I'm just gonna move forward in the interest of time. So that was rehost for you, right? Now pivoting over to the next strategy, which is replatform. Now if you really take a step back and look where we started, we had a traditional three-tier web architecture, and then we got the customer moving from the legacy monolith three-tier web architecture to a rehosted architecture on AWS. Now, what if the customer comes back to you and say, you know what, we have had enough fun with the workload running on AWS. Why not we just take a step forward and modernize our workloads, right? But then the customer is still not ready to really get into the latest and greatest of the technologies, but they still want to benefit from additional cost savings beyond what the rehost mechanism gave them, right? So that's when replatforming can really help. And this is where containerization and containerizing the workloads on AWS will provide additional benefits. Now, I'm not going to really get into what is containers and what are the benefits of containers. Of course, you can all really explore those. There are enough articles online to really get a sense of what containers can do for you. But then in simple terms, if you really look at it, containers, there are a lot of benefits that you can really obtain, right, by containerizing the workloads. One is the improved resource utilization. So with containers, instead of you having to run an application inside a VM, containers can really improve your overall resource utilization, right? You can really very granularly set your CPU and memory utilization for better use of your compute resources within containers. So that way you can run a lot more, application services as containers within your containerized computing environment. And additionally, it gives you much more flexibility. Scaling wise, you will be able to quickly scale as opposed to your EC2 instances. And then testing wise, and even the cost, the improved return on investment that you really get with your containerized workloads is far better when compared to running your application on EC2 instances. So there are significant benefits there. I'll leave it at that, but I'll definitely encourage you all to really learn a bit more about what containers can do. But then the focus of this slide here is to really show you how the rehosted architecture on the left, which which is still a fleet of EC2 instances running the monolith application, can be transformed as containered application running on AWS, which is the architecture on the right. So the architecture on the right is no different from the one on the left, but then the only difference that you will see is that the EC2 instances have now been transformed as containers running on AWS. Now, the container offerings on AWS, there are two types of container offerings. One is ECS. I did see someone dropping ECS on the chat at the beginning of the call. ECS is a native container offering on AWS, right, which is called the Elastic Container Service. And then we've got the Kubernetes version, which is the EKS, Elastic Kubernetes Service. So if you're someone who's got a background in Kubernetes and you're wanting to explore that Kubernetes thing in you on AWS, then EKS might be a good fit rather than just you having to level up on ECS. EKS might be a good fit, right? But then for most scenarios, at least from my experience, a lot of the customers will be relatively new to containers. For such customers, ECS naturally will be a good fit because ECS complexity wise is a lot more less complex compared to EKS, right? Kubernetes in general. So how do we go about making this transition? How do we go about containerizing an existing workload on AWS? So that's where there is a command line tool that AWS provides you called the app to container. Now, what app to container does, I'm just going to give you a high level mental model as to what happens with the app to container. So app to container is a command line tool, which when you have that installed and configured in a working machine, it's going to perform a sequence of steps. So the sequence of steps can be broadly classified into 4 different categories, which is highlighted or which is pictured down below. Discover and analyze is the first category. Extract and containerize is the second category. Creating deployment artifacts and then eventually deploying to AWS cloud. So but then what really happens task wise is basically what is called out in each of the respective arrows pointing to the application server on the left here, right? Now, this is a very fictitious application. Say if you have an ASP.NET application server that's running on-prem, and if you want to containerize that, right, as a containered workload on AWS. So what does app to container do? You have that installed and configured in a working machine. You run the app to container tool, right, in your command line or however in a programmatic way. So what it does is it is going to discover all your application sites. If you've got this being the Windows server, it's going to discover all the IIS sites which are capable to be containerized, right? Now, if you've got one or many, it's going to list down each of those web application that is going to prompt you and it's going to let you choose which one would you like to containerize, right? All of this is going to be taken care by the tool itself. It's just that it's a very self-driven command line tool. It will just prompt you to feed your response, and then it'll take care of everything behind the scenes for you. And the third thing that it does after you have designated the application that you want to containerize is analyzing the dependency for that particular application. So when you say analyzing dependency, it is all the network dependencies, the port dependencies, anything to do with the application itself will be analyzed. And then if you've got the database that is also running within the same application server, it will also detect that, and it will also have you update the database connection strings, right, that you want to update for the database that you have set up on AWS. That way it can really map the connection between the application as well as the database. And then the last thing is to extract all the necessary artifacts pertaining to the application server and make it all ready for containerization, right? And once it has got the artifacts ready, the next step it does is to push the artifacts into an S3 bucket that itself creates and manages within the AWS environment on your behalf. And that is the S3 bucket, which is going to house all the artifact necessary for the application server that is going to be containerized, right? Now, on the AWS, there's going to be a few different things. One, the tool itself at that point, app to container, the next step that it does is to build the image as a container image. And then for the container image, you're going to have a repository where the image can be deposited, right? And that repository on AWS is called Amazon ECR, Elastic Container Registry, and that is where the container image that is created and built by app to container will be registered. Okay. Now, the next step is where you're going to be choosing which orchestration platform, which container orchestration platform you're going to be choosing. Whether ECS or EKS is totally your preference to make. Whether if you happen to choose ECS as your choice, then app to container is going to register and create a task definition, ECS task definition for you. Think of task definition as a sequence of steps, right? That app to container and the task definition is going to say to the ECS engine, control engine, to really perform necessary actions. Okay. Alternatively, if you happen to choose EKS as your option, then you're going to have your own deployment file that will be generated, and that will help facilitate the creation of the AWS infrastructure for you. So that is roughly the high level of what really happens behind the scenes. Now, remember, all that we just discussed right now, you don't really have to do anything at your end. All of these that you're seeing on the slide will be done by the tool itself, the app to container tool itself. All that to do is to really help facilitate the necessary inputs as and when it prompts you. Okay, as simple as that. Very powerful tool that can really help containerize your workloads for your customers, right, on AWS. Now, this is a logical architecture for what an AWS looking architecture will look like. On the left, like I said earlier in the previous slide, you're going to have to install and configure the app to container in a working machine or in a worker machine. From there, it can really pull to each of the web servers that you want to identify and containerize. Okay. And the resulting architecture on AWS will look something like this. Pretty much the same networking boundaries. You will still have the VPCs, the availability zones, A, B, how many availability zones you get to choose. And then here you can see you have public subnets, private subnets, and then your fleet of EC2 instances. This time, instead of EC2 instances, it's going to be the instances within the ECS cluster, right? I have chosen ECS to be my container orchestration service, Elastic Container Service, and ECS behind the scenes, it's going to have a cluster of EC2 instances, which is going to have my application running as containers. Okay, within an auto scaling group, right? If you happen to choose EKS, then in this diagram it will be EKS cluster instead of ECS. Okay, the data tier remains unchanged. It will still be RDS running as primary and secondary across both availability zones. You will still be able to create and put together a code pipeline using our code services, which is what is called out down below. You have the code pipeline, code build and deploy. Or if you're familiar with Jenkins, things of that nature, any other CI/CD tool that you're familiar with, you can still continue to use that and integrate with this ecosystem running on AWS, right? You may not necessarily want to use ECR for container registry. If you happen to be familiar and are using a different container registry, that's totally perfect as well, right? No compulsions. AWS environment seamlessly integrates with any other non-AWS tool or environment. It's just that you really have to have a familiar understanding of how the integration works. Or if you're really starting your journey afresh, the most natural, easiest way is to really rely on the cloud native services from AWS. That way, it makes it a lot more easy for you to put together a working architecture. Okay. So that's basically what app to container can do, and this is the replatforming aspect of your workload modernization. Okay, I will stop there. Any questions so far for me on the chat? How are we doing so far? Is everyone still following me? Any questions from anyone on the rehost and replatform thing that we just discussed? Okay, following a lot easier. Update, I'm gonna just changing the image. Yep. Okay, excellent. All right, looks like Everything is all good. So let's just move on with the last part of the conversation, which is the refactoring aspect of the same three-tier web application that we are continuing to discuss. Right now, again, for the refactoring aspect, how does the same three-tier application architecture look like when you refactor it on AWS? So this is a sample representation of what it looked like. Don't get perturbed, or don't get scared by looking at this. We'll just break it down as we kind of discuss each of these components. But this is a view of how a modern looking architecture, a truly modernized, a truly refactored architecture on AWS for the same three-tier application. Right now, if you really look at that particular architecture, which I believe you guys are still able to see my screen here. So if you really look at that, this is a modern architecture on AWS, and it is still a three-tier web application based architecture. Right, there's a lot of same elements here, like the data layer, the logic layer, the application logic layer, and then the presentation layer as well. But then the way it is refactored on AWS is what is actually driving the most value for the customer. Right, the differences here is specifically what we are looking at this architecture. It is still a single microservice. Right, this service really performs a specific business function, and if you really look at our customers, many of our customers run dozens and hundreds or even thousands of these kinds of services, right, in a real-time environment. And then integration and communication wise, we're using a combination of events, messages, and queues, as you can see in the image. This is more so to really facilitate communication between more than one services within one service, or one component within a particular right. So events and queues and messages is basically how that inter communication between services will happen in a modernized, refactored application based architecture. Okay, and a purpose built data strategy. Now this is where I kind of alluded in one of the previous slides. It is important to identify the right database, right fit for purpose database for the right use case. And we'll get to see what those different types of database are in just a little bit. But that forms your data tier. Right, and finally, what you don't see here on this architecture is storing the state of the application itself, right, which is an important consideration when you're really dealing with a web application. How do you go about storing the state? Right, for a stateful application, you really will have to have a mechanism to store the state. If it is stateless, that's perfectly fine as well, but you really have to factor in all of those changes when you're really modernizing such an architecture on AWS. And of course, you have the APIs on as a front end that is going to help really render your traffic into your AWS architecture. Okay, so that's my high level into the architecture itself. Now let's just go ahead and break it down into smaller chunks. Now, if you really look at it, the very first question that one will get by looking at that modernized architecture is, how do you go about breaking the monolith? Right, now my application has got a lot of different business functions and logic within it. How do I go about breaking it? There are so many different ways of how one can really break the monolith. The most common approach is to really follow the domain driven design, where if you really apply the domain driven design, you really go about breaking down your core monolith application logic by business domain. Right, so that's why you really work very closely with your business analyst to really help understand the application nature itself. And I need to identify what are those core business areas that are a good candidate to break them down as individual microservices. Right, so if you really look at this particular example, this could very well be an e-commerce application. Right, if you look at an e-commerce application, you've got multiple different business logic that can be broken down by business domain. Right, so you've got the invoicing, you've got the product catalog, shopping cart, notifications that you all see here as individual boxes. Each of those can very well be an independent microservice in itself. Okay, now if you really look at it, so once you identify what those individual business logics are, then you go about breaking them down into their respective microservice, and then the next step is to really identify the appropriate compute engine, right, where you want to really run that particular microservice logic on. Now, notifications happens to be one of those one of those service that we just broken down. If you really follow the previous slide here, we had multiple different business logics, but then this representation is to kind of show you that notifications is a service that is just broken down as an individual microservice, and then you've got an API gateway upfront, which is acting as a facade from where the customer traffic will be entering into your notification service. And then the core logic of the notification service itself is being rendered and processed using a Lambda function, right? So now note that is a separate microservice, and the rest of your monolithic application is still running within your containers, right, as a separate architectural construct. So this is how you go about refactoring your existing monolithic application one service at a time. So in this particular architecture, you will see that you now have a new service in notifications, which will still have some level of dependency with your existing monolithic application that is running as containers, and then your containered application will still have its own dependency on notifications, right? So you will still have to facilitate the necessary or rewrite or reroute local invocation calls, which earlier happened within the same monolith code, now being made across the new notification service, which is now a microservice, right, that is created. So all of those changes will have to be factored in as you start breaking down your monolith into independent microservice. This is just the very first example specific to the notification service alone. Now if you really take that notification service forward, what we have done is we broke down the notification service from the core monolith, but the data connection for the notification service was still pointing to the original database, which is still shared for the entire monolith itself. But is that a good practice, you think? Probably not, right? You don't necessarily want to have your new services as well as your monolith all being connected to the same database. Instead, you really want to just have a dedicated data store for the extracted microservice, right? So having its own fit for purpose data store for each of the respective microservices is always a very good design when it comes to refactoring applications, right? Not only on AWS, this is a very, very generic rule of the thumb, is to really have the microservice tied to its own data store. So that way you have a lot more autonomy and a lot more control over the modifications of your code or anything that you will have to do for that particular service. You don't necessarily have to depend on the additional services, right? If you have a particular data store being commonly shared across multiple services, then the release cycles or any changes that you will have to really make will really consume a lot of time. So that is what this particular diagram says. So this is where you arrive at a point where you now have that individual monolithic application broken down into independent microservices, each one of those now having its own individual data store. And the communication between each of these services will be made through REST API calls. Okay. And this is a slide where I was just alluding to a little bit earlier. On AWS, you've got different types of database options. You've got relational database store, which is basically what we've been dealing with all through this conversation, RTS. But you've got different other data sources, as you can see from left to right, depending on what your core use case really is. If you're really dealing with content management system, if you really want to have high processing power, then Amazon Document DB or even DynamoDB, if you're dealing with key value pair, will be a good fit, right? Or if you're really dealing with the social networking recommendation engine sort of use case, and then want to make connection between different personas, different people in a typical social networking fashion, then a graph database, Amazon Neptune might be a good fit. So remember that there's plenty of options when it comes to dealing with data stores. It is important for you to understand the core business logic and the customer use case and determine the fit for purpose database. Okay. So taking that conversation further, so you've got the notification service. Now we've got its own data store in the form of Amazon DynamoDB, right? Now that's one service extracted as its own independent microservice. So that way, I'm just going to skip past these slides in the interest of time. Yeah. Sorry. Yeah, what I wanted to show is so that way yeah. So that way, so this is just one example, and that way we're gonna have if you just remember the very first slide of that monolithic application, we had each of those individual boxes as business logic. So eventually, what you will end up having is each of those individual boxes will be its own microservice, all broken down by the original from the original monolith. If you were to just break all of those business logics into its own microservice, and then you will be left with no more monolith code at all, right? All that you will then have will be the microservices themselves, and then you will establish communication between them by means of API, REST API calls. Okay. So that is that, and I know we are coming at the top of the hour. I do have a few slides that I don't think I'll be able to cover, but in the interest of time, I am just going to skip past the slides here. So this is the resultant architecture that I really wanted to show. So each of those now will all be its own individual microservice, and then the front end will be an API gateway. Think of API gateway as the facade, which is gonna be the proxy for filtering down your customer traffic, and then the traffic will be then broken down into each of the services, microservices, depending on the nature of the request itself. Okay. All right. Yeah. But other than that, this flow chart here, I just want to give you an example of. I want to take an example of a .NET application, and just wanted to summarize all the three strategies that we just discussed in the call today: rehost, replatform, and refactor, and how the decision tree look like for a .NET application. Right? I'm going to leave it to you all. Just take a look at it. I'm pretty sure if you can just follow along the flow chart, I'm sure you'll be able to make sense. And then I want to leave you all with additional couple of slides just to kind of give you a sense of what tooling options you have from an application modernization standpoint. From an application standpoint, you have all of these different options. So microservice extractor for .NET. I know we're right on time here. If you can just hang on for a couple more minutes, I'll just get this all done with. We talked about breaking down the core monolith into independent microservices by business logics. If you are not familiar with it, if you don't have your developer team confident enough to their micro breakdown themselves, then this particular tool can help accelerate that microservice extraction for you. So great tool. I highly encourage you to explore microservice extractor for cases where you or your developer team do not really have that exposure into the microservices world. So likewise, for application, for database, you have the modernization tooling from AWS, all the way from database migration service to schema conversion tool to Babelfish for Aurora PostgreSQL, right? So with that, I will close the call. So that's my LinkedIn barcode. If you really want to stay in touch with me, if you have any questions, I know we've come up on time. Unfortunately, that we had so much of content to cover. But if there's any question that you really want to ask me outside of this forum, I'll leave this here for you. You can just scan that barcode and reach out to me on LinkedIn. I'll be more than happy to answer your question. Anything on this particular topic or anything otherwise related to this particular topic as well. Okay. With that being said, let me see if there's any question on the chat that I can take before we can close. Yep, I'll make sure I'll check with the Codementor host and make sure what's the right way to share that deck with you all. Okay. Yeah, absolutely, Damien. Thank you for that suggestion. I really wanted to incorporate that into the session, but this is a very vast topic, and I can only do so much inside 60 minutes. I'll take that suggestion. Maybe probably as an iteration two in the next session, we'll dive a little bit more deep into the serverless aspects. Okay. Yeah, for sure. Any other questions, folks, before we drop off? I hope this was helpful. Helpful little conversation. Hope you all learned a little bit something. And if there's anything that comes up, just let me know. Okay. Yeah. Thank you. Any other question from anyone before we close the call? Thanks, Hector. I'm, I'm, I'm seeing a lot of questions asking for the slides. I do not really know what is the formal way of sharing it, but I will figure it out and make sure you all get the slides soon. Okay. All right. Okay. So I don't really see any questions on the chat coming, but Damien, I will definitely take your suggestion, and I'm pretty sure, given the interest with this forum, hopefully this was a productive session. We will definitely meet again with a much more deep dive conversation into some of the aspects that we were not able to touch on today. Okay. Thank you, everyone. Have a great rest of the day, and we'll meet soon.